We made a reamer the other day, and I don't think a lot of people caught on to what was going on there, but it's fairly common in this business. And we used CBN, cubic boron nitride, when we cut that one. And I've done that with drill bits, which really makes life a lot easier than what it used to be. The first time that I had done something similar to that, we made a reamer out of a drill bit, so it was only a 2-flute reamer. And we used a tool post grinder, and the master machinist that was at the shop had me set up the tool post grinder and grind for hours. It took forever so that we could make this reamer. We tapered the whole drill bit so that we could make it to fit a taper that was correct for tie rod ends. And you find out, at least for pretty much all American equipment, and I really think the metric stuff too, it's all the same taper. Doesn't matter. I've worked on off-road haul trucks with a ball stud that's 2 inches in diameter. It's the same taper as the one for your Jeep. All of them, they're the same taper. Different sizes, but the taper is the same, which is kind of neat. So you can make yourself a set of those if you wanted. And I made some for up at Red Dog Mine when I was there. I'm sure they're gone by now, but I made some pretty nice ones there for doing trucks. And anyway, after making it to shape, then he showed me coming in here and bluing it, and you're just leaving the cutting edge and grinding the stuff away from the cutting edge. Then you do that by hand. Now you could do that on a tooling grinder. If you had a lot of the same tool, you wanted to be able to duplicate a tooling grinder once you set it up, is a better way to do it. You could set it up on our surface grinder like we've got over here. But by the time we set up the centers and fuss around with that, it took me 4 minutes to grind those, to relieve those flutes. If I was setting this up, it's going to take me an hour just to get it all square and set up before I even get a finger stop built for it, which I don't have. So, same idea today with the cubic boron nitride, because cubic boron nitride will cut a hardened high-speed steel tool. I tested it when I first started working with cubic boron nitride. I took some 8% cobalt lathe bits, square ones, set them off center and took a nice interrupted cut on a lathe, and it just made nice little chips, and it was amazing. Since then I've used them for all kinds of things. So that replaces a lot of the grinding. We still do the relieving, but let's say you don't have CBN. Let's say we're going to do this old school, and at the same shop where I had made that taper, we used to do a whole bunch for screws like this, generally smaller drill. This is a good, easy one to see. And what we would do is we would make the drill so that it did the countersink and the drilling both. Now you can buy that tool also. It exists today. But if you didn't happen to have one, you wanted one fairly quickly, you can grind it yourself. This stuff is not as exacting for a functional tool as you would think. The problem you get into with a lot of handmade tools like this that will work is the slight variations when you're setting up your machine. You have to do too many compensations for the differences in the tool when you do it again. That's where a production-made tool, you got time, you're doing production work, go buy the tool. You know, I'm not saying do this for everything. I'm just saying it's a skill to remember. It's another one of those things you can do. Okay, so this is for a 3/8 hole. Okay, we're probably going to want a little bit of clearance in the 3/8 hole. This is 3/4 inch drill bit. And so if we take our 3/4 off of the 3/8 off of 3/4, we got 3/8 in the middle, means we have 3/16 that we want for a step on each side. So that would be 0.187. So if we figure an extra 15 thousandths clearance, we just say 180. So we're looking for about a 180 step on one side in here. And if you just cut it right at, and I know that's nowhere near what we need, but you just cut it at the cutting edge to start with. That's all you want to measure. See, we're down 62 now. It's a number. You don't have to grind it all away. You don't have to, just cut the part that you care about. Just get the part you care about. Get it down to size. Okay, I got 88 now. So still need to go a long ways. I'm going to go ahead and relieve some of the rest of it because it's getting hard for me to grind just that one spot without relieving the rest of it. Long, long ways to go. This is actually easier with a smaller drill bit, but harder to see. Might have to dress that wheel. $120. So I got about a 16th to go. And it's amazing as you get down close to it how quickly you can take off more material than you want. I do want to dress that a little bit. Where is one of our... Trying to get a squarer corner in there. Pretty close. And I'm going to be slightly off in my measurement here. Depth is what I used to use most of the time. There. Somewhere in there. Not really quite what I wanted. I'm gonna rough this other side down. Part of the problem I'm getting there is getting my measurement because the smaller bits is not quite as much of a problem when you're doing smaller sizes, but there's a difference because this is at a different height than this one as it rotates. It's a different point on the circle. So measuring directly is not really giving me the diameter difference that I'm looking for. Or at least I think it won't. It's hard to say. It'll still work. When we're done, it'll work. But see, if you were doing this on a lathe, you'd take your CBN and you just turn this down to the size you want it. And you just set your angle. And that really makes it easy in this day and age. What I'm showing here is the way we used to do it many, many years ago. The main thing that we used to do that for was a rather interesting product that I was surprised to be involved in. Even at the time, it seemed like, wow, we're doing this here today in 1980. We were making steel sled runners for the natives that were still using dogs for real transportation, for hunting, trapping, going to visit people. They weren't the ones that weren't using snow machines. This wasn't racers. This was the normal, everyday, they wanted a dog sled, they wanted steel runners. And that's why we made these bits up. We would make, and I don't remember what the spacing was, but we'd make them up in advance. Don't even remember the size, but it was just we'd take out a piece of flat bar and we'd lay it out with soapstone. And I had asked about that too. I said, well, when they go to replace these, they want them fit. Oh, they'll deal with it. They'll move it, do something. Don't worry about it. It's the way we do it. And we were carrying on something that had already been done for well over 50 years in this town. I was just at the tail end of it. And what we would do is we would sell those to Samson's Hardware. Samson's Hardware stocked a few standard sizes, whatever the foot was. I don't remember what their standard sizes were. Sometimes we'd make custom ones. And then later on they got in, all the people started doing plastic runners and things. And plastic, they feel like they can drill their own anyway. But we did steel ones. They would send them out to the people out in the bush. Nobody even saw each other. But I thought it was pretty neat that we were making the sled runners. I lost track of where I was at on which one. I think I needed to go a whole lot more on this side. Yep. Did we have a customer? Making noise in there?
I think that was heat expansion on that drum.
Oh, okay. We can get those too. Okay, somewhere close. Okay, you need to make sure you've got radial clearance. And you want to sharpen the front. I'm just doing that to bide time before I do the next step. And think about it, because it's been a while. So I split the point. Now, this point here, you could get really fancy. These are 82 degrees. We could go get a gauge, but it's so much easier. Just take the screw you got in your hand and use the screw as a gauge. But it works. That's what I've done for years, and it's functional. And it's still going to be just freehand, and then check it against the gauge. And what this all comes back to, doing this hand work like this, and you still have to do the hand relieving, even if you put this on your lathe and cut nice even angles, you need to do your hand relieving on it so that you've got your clearance back behind it so it cuts. But this all comes back to learning to sharpen lathe bits and drill bits by hand. When I first learned this in college, I went, oh, come on, guys, they got machines. Greatest thing you can do if you want to be a real machinist, if you want to end up being a master machinist. You get more understanding of how, even if you design tools later on a computer sitting there to have somebody else precision grind them, you see what works, what doesn't work, you know how the grinder affects it, you get used to the reaction. It took an hour every day for a month before I could learn to grind a drill bit even halfway decent. And it seemed like this terrible torture I had to go through. One of the best things I ever did. They forced me. I'm glad they forced me. I force other people. That's, and also some people I don't force. My mom's boyfriend. He decided that he wanted to, he had some broken drill bits and he thought that he could go around to garage sales and trade people because they had all kinds of dull ones he'd find it. And he just thought it would be fun to trade and get good drill bits. He'd go trade them at garage sales for ones that needed sharpening and needed work. So he asked me, what would be the best, because I was a pretty well established machinist by then, what would be the best drill grinder I could get? And I said, bench grinder. Learn how to do it. And I didn't think he ever would, but he did. I saw him a couple months later. I was traveling back and forth at that time. He was down in the States. Him and my mom both have passed away by now. But I showed him how to do it. A couple months later, I'm like, yeah, you pretty much got it, and gave him another little pointer. And he had probably 5,000 drill bits in about a year because he had been swapping, trading, getting out all nice, sharpened, setting in racks. Yeah. Only up to 1/2 inch, just the normal homeowner sizes. But boy, he got into it and he was doing it right. And you can do the same thing for socket head screws, except you make straights. It really is a lot easier and nicer to just turn it down on a drill with collets, but you may not all have CBN, you may not have collets. Holding a drill nice without a collet system is pretty tough too. You can do it, but it's not nice. Okay, that one's fitting fairly good. That's fitting fairly good. Look relatively even. May not be perfect, but let's go see if we can drill a hole. That's enough. Oh, hadn't thought about that. We go deeper to get a hole through it so that the screw will fit. I had forgot about that fact, that a thicker piece, we gotta go deeper. Haven't made it through it yet. I was just thinking about making the taper at the top. Because I basically only made it for going through like 1/4 inch material. So now where did I put my screw that I had? Right there, okay. So, not as pretty as it could have been, but it would work for dog runners. Actually, I would have gone back and reground this bit if it was one for the dog runners. It didn't come out quite as good as what I used to do. The littler ones were easier to do. And yeah, we should set one up. Simple one would be to set this up for a socket head screw, so it's just a straight turning, something that people would do now and then. Making a one for a, you can get countersink screw cutters. And I try to encourage people to buy tools too. When I make these quick tools and things, it's not, you can't have every tool. The most of your money for tooling is not the tooling that you use, but it's what you stock, or what you didn't stock and how much it cost you to make the tool. You know, because if you're going to do the job, you're going to need some kind of a tool. If it's not a good tool, it's not going to work as good. If it is a good tool, you spend a lot of money to it. If you bought one in every 64th plus every metric size, every possible thread pitch, yeah, I got hundreds of thousands of dollars I've spent on tooling here. It doesn't look like anything. It's nothing. And I've worked at a lot of shops that didn't have nearly what I have for tooling. But it is the tooling you don't use is what costs you. I still, a lot of times I'll pull out a tool that's never been used, but I bought it because it was part of a set. I wanted all of this particular tool. So we bought them all. And it's part of overhead. If you don't buy them all, customer comes, oh, let me go see if I've got that size. Or you just bid it as if you don't have any tools. Yep, that's going to take about 3 weeks. Yep, 3 weeks, that's it. First 2 weeks to order the tools we need.